chapter, apa nama dia? Chapter 4. Share screen. Okay, last week kita dah tengok chapter 3, _1, estimation. Macam mana you are going to calculate the okay, sekejap. Okay, kita continue with hypothesis testing, the second part for chapter 3, where in this chapter you are going to learn about how to do the hypothesis testing, what kind of test to be used, either the normal test or the t-test distribution, and then what are the conclusion can be drawn from the hypothesis testing. Okay, nampak tak saya share slide sekarang? Oi, nampak tak?
Nampak, Doktor.
Nampak, okay. Sofia, Yaya ada?
Ada, Cik.
Boleh kan masuk?
Boleh.
Okay, hypothesis testing. Take a look at this one. Learning outcomes. At the end of this chapter, you should be able to use the concept of hypothesis testing to identify the use of Z-test and T-test for testing on mean and proportion. Okay, so remember kita belajar dua parameter juga. You are going to learn only about the mean, X bar, and also proportion is P, okay, atau P hat. And then to apply all methods involved in hypothesis testing for mean and proportion. And so on the three learning outcomes. So concept of hypothesis testing ni selalunya bila once when you collect the data from the experiment, dia ada satu assumption atau satu andaian that we want to test or we want to attain as a set. Okay. For example, satu syarikat dia buat kereta and then dia buat testing on the car. So dia nak tengok berapa masa, how many time does it takes untuk kereta to stop when the brake is push. Okay. So daripada situ dia buat test and then the assumption dia maybe masa buat kereta tu it takes only 2 second for the car to stop when the brake is pushed. So is it true or not the claim? That is why we are going to do the hypothesis testing and then draw conclusion either to support the claim or to deny the claim. So that is the concept of hypothesis testing. So by definition, make sure you understand this chapter sebab dianya kita akan buat the hypothesis testing from this chapter on up until chapter 8, the last chapter. So everything is related to, actually the main idea of statistic is rather than doing the data analysis is also to do the hypothesis testing. Okay. So by definition, hypothesis testing typically begins with some theory, claim or assertion about a particular parameter of a population. Okay, parameter, for example, you want to do the claim on the mean or maybe also on the proportion or standard deviation or any kind of parameter. But the thing that we are interested, the parameter that we are interested in this chapter is only on the mean and also the proportion. So from there, we want to test on the proportion or on the mean, and it will end up with a decision that pre-assume about the entire population based on the sample statistics. So hypothesis testing is related to a testing that will bring a conclusion. Okay. So ada andaian dan daripada andaian tu kita akan buat testing and we want to see what are the conclusion. Sama ada andaian itu disupport or not. Itu adalah the idea of hypothesis testing. Okay. So we have the null hypothesis and also the alternative hypothesis. For the null hypothesis, we denote it as H null. Okay. A null hypothesis refer to any hypothesis that we wish to test. Sebarang hypothesis yang kita nak test, that is the null hypothesis. And dia punya complement is known as the alternative hypothesis, H1. So it will represent the question to be answered and also the theory to be test. So itu adalah kucing aku ni. Itu adalah apa nama dia? Alternative hypothesis. So selalunya nanti once you buat hypothesis testing, awak akan listkan apakah dia punya claim dan apakah what your H null and what is your H1. So contohnya dia kata the mean time kereta Honda example adalah 2 saat. Betul atau not? Betul atau not? Is it true that we have sama ada 2 second versus mean dan 2 second? Okay. So hypothesis ni adalah complement untuk null hypothesis. So this is about hypothesis testing. Okay. For example, okay. So once awak ada H null and H1, and then the next one you are going to have null of H1, okay, or vice versa. So the rejection of H null lead to the acceptance of H1. So once when you do the H null H1 and then kita akan buat dia punya test. So dia punya keputusan, decision is sebab awak ada 2 H null and H1. If you H null means awak akan accept H1. Okay. And vice versa. If you accept H null, kita akan reject H1. Itu maksudnya. Sebab selalunya once bila kita buat conclusion, kita akan cakap reject H null or accept H null. Okay. Ini conclusion kita. Kalau awak cakap reject H null, meaning that conclusion awak will be based on H1. But if you say accept H null, meaning that your conclusion will be on the null hypothesis. So let's see. Null hypothesis. So what kind of the sampling distribution of test the statistic is divided into 2 regions, which are rejection and also non-rejection region. Okay. For example, if the value of the test statistic fall into the rejection region, it will lead to rejection of H null. And the critical value is the value that is divided in non-rejection region from the rejection region. So just like awak akan ada nanti, so dia jatuh dekat mana? Dekat dalam ni ke atau dekat luar? So kalau jatuh dekat dalam, katakan ini adalah awak punya rejection region. Okay. So tengok test statistik jatuh dekat mana, then kita boleh cakap either we want to reject or accept the H null. Okay. So this is the theory. It's a bit confusing lah sebab the theory first, tapi tak apa, nanti kita tengok example, you will get a better understanding. So, yang awak akan belajar dalam this subject, kita ada dua. Okay. Hypothesis testing untuk one population dan juga dua population. One population tu contohnya kalau kita so example if we want to test on two type of car, Honda dan juga Toyota. Siapa punya mic on?
Ni suara selalu sangkut tadi.
Okay.
Tu.
So Honda and Toyota, hear me or not?
Kurang sikit sebab sangkut-sangkut.
Sekarang masih sangkut-sangkut yang melek ni?
Dia lag-lag sikit. Dia macam cakap sepatah, tak dengar sepatah gitu.
Oh, okay. Sekejap lah, tunggu sekejap. Line tak ni. Okay, sekarang boleh dengar clear?
Boleh.
Boleh, okay. So, yep. Basically yang awak akan belajar ada apa nama dia, dua jenis population. Okay, kita akan ada one population sekejap. So, dia ada one population atau two population. Untuk one population, for example, we do testing on one type of car. So, kereta Honda, dia nak tengok apa nama dia, testing on mean brake time yang diambil, berapa masa yang diambil for once you tekan the brake and also the car to stop, berapa masa yang diambil for that kind of process. So, dia tengok terhadap kereta Honda sahaja. So, is it taking 2 second, 3 second or maybe 5 second? That is an assumption. And then, lagi satu, kalau untuk two population ni, if we want to compare jenis kereta, for example, Honda and also Toyota. So, both car buat eksperimen yang sama and then dia tengok yang mana lebih bagus. Adakah sama masa yang diambil or something like that. So, itu adalah untuk two population. So, there are two type of testing that we are interested. Dua parameter, the mean and also the proportion. And then kita tengok dia akan ada, untuk one population akan ada dua jenis testing, one tail atau two tail. Okay. So, one tail ni maksudnya kalau one tail, it is for the case yang mana dia ada tanda lebih besar atau sama dengan, atau lebih kecil dan juga sama dengan. Two tail if you have the non-equal sign, non-equal sign. Okay. Sebab kita tengok kepada satu H0 atau H1 sahaja, satu ni sahaja. So untuk both one tail or two tail, you are going to have testing on the large sample atau small sample. So large sample atau small sample ni bawa daripada apa yang awak bawa belajar masa estimation, yang kita ada 4 case. Okay. Large sample sigma is known, large sample sigma unknown, and also small sample sigma is known. So itu semua akan follow Z distribution daripada chapter 3 estimation. And then kalau awak ada small sample and sigma is unknown, dia akan jadi T distribution. So this one carry daripada chapter 3_1 yang awak dah belajar hari tu. Okay. So nanti kita tengok, we will go through in a very deep what does it mean by one tail and two tail. And then untuk dua population sama juga, there are two type of testing that you are going to learn. That is either one tail atau two tail. And then you have a large sample and also a small sample. Sama juga dia punya type of testing that we are going to test on the two population for the hypothesis testing. Okay. So take a look at the one tail test of a test of any statistical hypothesis where the alternative is one-sided. Contohnya, gambar tak keluar pula. So where the alternative is one-sided, meaning that for this example, awak ada testing on the mean mu equal to mu naught atau mu less than mu naught, or you have mu greater than mu naught versus mu less than mu naught. Okay, so meaning that population parameter equal to what we call it, equal to the mean that we want to test. So why it's become one tail? Sebab tengok dekat dia punya H1, dia punya complement adalah satu sided sahaja. So kalau awak buat dia punya graph yang ini adalah lebih kecil. So this one, okay, that's why it's become one tail, because the complement dia H1 dia hanyalah lebih kecil. Yang ini setara, you can write either this one or you can also write this one. Sebab apa? Sebab dia adalah complement terhadap H1. Okay. So it is a left tail sebab mu is less than H null if mu is less than mu naught. Okay. So ini untuk case left tail. Okay. For the case of mu is less than mu naught. So this one, it is a left tail. So another one tail, if you wish to test H null mu equal to mu naught, atau we can also write it as mu is less than or equal to mu naught. And the complement is mu is greater than mu naught versus mu greater than mu naught, atau, okay, you can write is either way. So yang ini adalah sama dengan yang ini, cuma cara penulisan sahaja. So kenapa dia right tail? Because if you see on the H1, for this one is mu is greater than mu naught. That is, if you do the drawing in here, dia punya rantau penolakan is greater. So contohnya satu nilai dekat sini. So ini adalah awak punya rejection region. Okay. Lebih besar daripada mu naught. So sebab itu adalah dia satu sided. Kita nak tentukan one sided atau two sided, tengok dekat awak punya H1. Okay. So rejection tail is on the right tail. Dia punya rantau penolakan atau rejection region is on the right side of your table. Okay. So then only we have this is one tail test. And ada soalan tak so far? Senyap je budak ni. Dengar tak?
Tak ada, doktor.
Tak ada, okey. Ngantuk ke? Lagilah puasa kan? Okay. Okay. So, two-tail test, a test of statistical hypothesis where the alternative is two-sided, meaning that we want to test mu equal to mu naught versus mu does not equal to mu naught. Dia ada tanda tidak sama dengan, that means dia akan ambil dua tail. Okay. Okay. So this one. So dia akan jadi no. Dua tail is this one. Tidak sama dengan mu naught, it will be something like this. Okay. So awak akan ada dua sided. So yang saya lorikkan ini adalah dia punya rejection region, rantau penolakan. You want to reject H null. So the left and right tail, the rejection region is in both tails. So nanti kita tengok dia punya example lah. So test statistic is calculated based on the value of simple information, and the value is very important in determining the decision. Then apakah jenis test statistik? So first thing first, awak akan list H null and H1. Okay, H null and H1. And then tengok dia punya rejection region tadi. Rejection region. So from H null and H1 ni, you can decide, you can know whether your test is one tail atau or two tail test. Okay. So macam mana kita nak tengok rejection region tu, kita akan ada test statistik. Okay. Basically there are a few procedure that should be follow before we run the hypothesis testing. So kita tengok pula dia punya test statistik. Okay. So untuk population mean, tadi kita akan ada, if you take a look at this one, awak ada 4 case yang awak akan belajar. Okay. This one, you have one tail atau two tails, large sample atau small sample. So tengok dalam chapter 3.1 kita ada 4 cases. Large sample follow normal distribution atau sigma known atau sigma unknown. So basically untuk test statistik dia akan ada 3 case. Okay. Large sample and greater than 30 and sigma is known. Kita dah tahu dia akan follow normal distribution. Z akan sama dengan test statistik awak, Z akan sama dengan X minus mu divide by sigma over cert N. Okay. Atau large sample N is less than 30 and sigma is unknown, it will still follow a normal distribution with your test statistic is Z equal to X minus mu S over cert of N. And for small sample N less than 30 and sigma is known, it will still follow the standard normal distribution. So dia punya testing is sama. Okay. X bar minus mu sigma over cert of N. So ini yang awak belajar masa chapter 3 dan dia dibawa dalam chapter ni, hypothesis testing. Okay. So nak buat dia punya testing, kita kena tengok which test is suitable. Which case does it follow? Is it small sample atau large sample? Or is the standard deviation known or unknown? Okay, population standard deviation. Okay, so hypothesis statement, yang ini adalah list of all hypothesis statement. Okay, if you have Z equal to H null, mu equal to mu null atau mu less than mu not, or meaning that awak boleh tulis cara ini or this way. Okay, boleh juga kita letak mu greater or equal to mu not. Dia punya complement mu1, H1 is less than mu not. So Z less than negative Z alpha, dia punya rejection region. Kenapa Z less than rejection Z alpha? Because this one. H1 awak ada tanda lebih kecil. So dia punya Z ini adalah test statistik. Okay. Dan kita akan tengok negatif Z alpha dekat sini. So ini adalah dia punya rejection region. Okay. So dekat mana jatuhnya test statistik tu? Adakah dia jatuh dekat dalam yang saya berlorek atau dekat dalam yang saya tak lorek? So this rejection region, this is acceptance region. Okay. Apakah yang dimasukkan dengan rejection region? Okay. Rejection region membawa kepada keputusan reject H null. Okay. Dia punya acceptance region membawa kepada keputusan accept H null. Okay. So kita akan buat conclusion based on this statement. Either you reject atau accept H null. So boleh salin dulu, saya nak salin supaya awak nampak dekat mana dia punya location. Ada soalan tak so far? Oi. Soalan or not? Senyap je semua. Tidur ke? Yaya, are you there?
Ya, Cik. Ada.
Nabil ada tak? Tak ada?
Dia ada kelas lain.
Siapa dia dalam ni?
Saya dengan Amir je kot.
Tadi Amira Syafika tu nampak.
Dengan Amir lah.
Okay. Dan lain-lain. So, ini adalah hypothesis statement. Awak boleh tulis either way atau the next one. Ini untuk case one tail. Okay. So, ini adalah one tail test. Okay. So, the next one you have the statement mu equal to mu naught atau mu greater than mu naught versus mu less than mu naught and mu greater than mu naught. Okay. So this is the statement. Awak boleh tulis yang the first one atau the second one or. Okay. So dia punya cara or. So ini akan jadi one tail juga yang mana awak akan reject test statistic Z. Okay. If you get the value is greater than positive Z alpha. Meaning that if we draw the graph, so dia punya rejection region is here. Positive Z alpha is here. Okay. So ini adalah awak punya acceptance region and this is your rejection region. Okay. Reject H0. So this is also a one tail test. One tail test. Okay. So kena tahu dia punya konsep dekat mana lokasi yang you akan reject H0 atau dekat mana you akan accept H0 and so on. So the last test kita akan ada testing on the mean where you are going to have mu equal to mu naught versus mean does not equal to the population mean. So yang ini dia punya reject H0. So this is the statement. Reject H0 when Z is less than negative Z alpha per 2 atau Z greater than Z alpha per 2. Okay. Z greater than Z alpha per 2. Meaning that in this case, dia punya rejection region is here. Okay. This is negative Z alpha per 2 and this is Z alpha per 2. So this is a rejection region. This is your acceptance region and this is your rejection region. So this is what we call as two tail test. Okay. So itu yang dimaksudkan dengan one tail, two tail atau so on, so forth. Ada soalan so far? Before we proceed with the last two explanation and then kita tengok the step involved and how to do the example. Ada beberapa example saya letak dalam ni. We will go through one by one of the example. Okay. Done with this one, class? Oi.
Dah, Cik.
Done. Okay. Syed ada Syed?
Ada.
Ada. Puasa tak?
Ada. Ha?
Puasa tak?
Masuk. Ni masuk lah.
Okay. So, test for population mean lambat lagi nak buka kan? Berapa ni baru? 29. Okay. So, tadi kita dah tengok 3 case yang mana daripada this one. Okay. Daripada awak belajar masa chapter 3_1, kita ada large sample, sigma unknown, large sample, sigma is known and sigma unknown, and small sample, sigma is known. So, yang ini semua guna Z distribution. That is standard normal distribution. Okay. Sebab tu awak ada dia punya test statistik is this one. Z, and Z. Okay. So kita ada lagi satu case. Kalau ingat masa chapter 3_1, we have the small sample and sigma is unknown. Okay. And less than 30 and sigma is unknown. So it will follow T distribution. Okay. So dia punya test statistik, this is T betul kan? T akan sama dengan X bar minus mu S over surd of N. So it will follow the T distribution table. Meaning that kita akan refer table of T distribution untuk dapatkan nilai bagi reject atau accept H null. Okay. For this type of case with small sample and sigma is unknown. So hypothesis statement dia sama je, cuma yang berbezanya adalah test statistik. Kita akan guna T distribution and then dia punya inilah dia punya dekat mana awak nak reject, dekat mana awak nak accept H null. Okay. Done lah with this one. So, kita tengok dia punya hypothesis statement. For this case, if you want to set mu equal to mu naught versus an alternative mu less than mu naught, atau mu is greater than mu naught and mu equal to mu naught. Meaning that we want to test or adakah mean dia sama dengan satu value, population value, atau versus the alternative lebih kecil. So take a look at this one, dia punya H1 is lebih kecil. So rejection region, reject H null bila T less than negative T alpha n minus 1. Okay. So dia akan jadi one tail. This one. Ni negative T alpha n minus 1 degree of freedom. Kenapa ada n minus 1? Sebab ini adalah degree of freedom bagi T distribution. Okay. So dia punya ni kita tengok dekat H1 H1 tanda lebih kecil. So dia jadi dekat one tail test. Belah kiri. Okay. Then kita akan ada H1 mu equal to mu naught versus mu equal to mu naught, atau boleh juga mu less than mu naught versus dia punya complement is mu greater than mu naught or mu greater than mu naught. Complement bagi this one. So kita akan reject H null if test statistic, this is your test statistic, T greater than T alpha n tolak 1. So this is your rejection region over here. T alpha n minus 1. So yang ini adalah awak punya rejection region. This is your acceptance region. Okay. Okay. T alpha n minus 1. This is also one tail test. So kita akan gunakan T distribution. Sama juga untuk case yang keempat. So lagi satu kita ada two tail. If it happens, you want to test whether the mean equal or non-equal sign. sama dengan atau tidak sama dengan. So rejection region when the test statistic, this is your test statistic tadi yang kita tengok dia follow T distribution is less than negative T alpha per 2 N tolak 1 atau T greater than T alpha over 2N minus 1. So it will be two-sided like this. You are going to have your negative T alpha over here and T alpha over here. So this is your rejection region. Ini your acceptance region. And this is your rejection region. Okay. So dapat Ini adalah untuk two-tail. So done with the explanation, kita akan tengok example. So that you get a better understanding how to do the hypothesis testing. Done, class? Oi, dah? Or not?
Dah.
Dah, okay. So, these are the steps to perform hypothesis testing. So, first thing first, state the null and alternative hypothesis. That means nyatakan apakah awak punya H null dan apakah awak punya H1. So, kita nak guna tanda mana? Lebih besar ke, lebih kecil ke atau sama dengan dan tidak sama dengan. Okay. Then, choose a fixed significant level that is alpha. Normally, kita akan ambil 10%, 5% atau 1%. That is alpha can be 0.1, 0.05 atau 0.01. 0.01. Okay. Then choose an appropriate test statistic. So ni awak tengok case 1, case 2 atau case 3 atau case 4. So case 1, case 2, case 3 yang ini akan ikut Z distribution dan case 4 akan ikut T distribution. Okay. So that is the appropriate test statistic tadi yang kita tengok case 1, case 2, case 3 atau case 4. So the next one, establish the critical region based on the value of alpha. So yang ini tengok rejection region. Okay. Maksudnya awak ada one tail atau two tail. Yang tadi. One tail or two tail like this. Okay. Then baru buat conclusion. Not decision. Make decision, establish the critical region based on alpha. Dari sini awak akan buat decision whether to establish a critical region based on alpha. So from here, we will make a decision. Okay, whether to reject apa hal tulisan aku tu noun. Whether to reject H null or accept H null. Okay. Then yang kelima baru make a conclusion. So ini adalah berkaitan dengan hypothesis testing. Dapat So kita tengok example. Ada soalan kelas so far?
Tak ada.
Tak ada. Okay. So, test awak confirm 7 hari bulan. Okay. Malam 7 hari bulan Mei, seminggu sebelum raya. Raya pun tak ada ke mana kan. Pukul apa nama? Pukul 8.30 malam sampai ni. Okay. So your test is confirm 7 of May. Masuk chapter 1, 2, 3. And then, yep, that's it. Okay, so kita tengok example. How to perform hypothesis testing. Okay. Okay, example 7.1. Okay. Dia kata, it is known that on average, it's mudah eh? Can we proceed with the example? I want you to focus on the example to get a better idea how to perform the hypothesis testing. Done? Semua?
Kan.
Done eh? Syed, done?
Dan.
Amar ada Amar? Amar ada Us, Adwa?
Tidak.
Tidak.
Dan. Elok sikit.
Jadi korang eh. Tak baik memfitnah. Gitu lah. So on average, a computer technician needs at least 3.2 hours to solve a problem on troubleshooting. Okay. So a random sample of 30 computers with this problem is taken and it is found that the technician needs an average of 2.8 hours and a standard deviation of 0.14 hours to solve the problem. So, what can you conclude? Test at significant level 0.01. So, cuba baca balik soalan. Fahamkan. So, dia kata secara purata, seorang computer technician perlukan 3.2 jam untuk troubleshooting problem with computer. Okay. So, dia nak tahu betul ke technician on average, seorang technician perlukan 3.2 jam. So, nak tahu betul or not, dia ambil random sample 30 komputer yang ada masalah dan dia buat testing. Dia dapati masa yang diperlukan oleh technician adalah 2.8 jam dan standard deviation 0.14 hours. So, apa conclusion dia? So, meaning that betul ke claim yang mengatakan dia perlukan 3.2 hours tu? In other words, dia bagi. Okay, you have 2 hours, you have 30, you have 2.8, you have 0.4 and also 0.01. Okay, 2.0, 30 computer. This one apa?
Yang kecil.
Yang kecil, betul. Okay. And then 2.8.
Min.
Min apa benda? Ada dua kan min, mu atau? Okay, betul. Sample min. X bar. Okay. 0.14.
S.
S. Betul. What is this 0.0001? What is symbol for this one? Oi, 0.01 apa? Sama. Syed, 0.01. Adwa. Daus. What is 0.01 represent?
Unit.
Salah.
Alpha.
Alpha, betul. Okay, alpha. This is alpha equal to 0.01. Tengok dekat sini. Significant level. alpha. You can have either 10%, 5% or 1%. So in this case, alpha equal to 0.01. So ada lagi satu, a computer technician need at least 3.2 hours. So 3.2 hours to refer to what? Refer to what? 3.2 hours.
Mu.
Mu, betul. So 3.2 hours ini adalah population mean atau mu. Betul lah, mu. Okay, mu. Okay. So yang ini yang saya gariskan, ini adalah statement, okay, that we want to test. Okay, this is the statement that we want to test. So meaning that itu adalah H0 dan juga H1 awak. Okay. So dapat So kalau tengok ni lagi satu, N equal to 30. Sigma is known or unknown? Sigma unknown. Okay, dia tak bagi. So dia akan case berapa? Case 1, case 2, case 3 atau case 4?
Right.
Banyaklah kau. Salah. Betul, case 2. Okay. Case 2. That means dia akan follow Z distribution. So awak akan ada Z test. Z akan sama dengan X bar minus mu over S per cert N. Okay. So, list down all the information as yang saya listkan dekat dalam slide. So, boleh salin dulu. Kuntil. Done, kelas. Oh, done.
Done, Doktor.
Done. Senyap dulu dah ni. Okay, so we want to do the hypothesis testing. Okay, the hypothesis testing. Okay, so first tengok steps on to perform hypothesis testing. State the null, state the H null. Loh, patutlah tak share screen. Okay, nampak tak? Saya share screen sekarang.
Nampak.
Nampak Okay. So first things first, state your H null and also your H1. Okay. State the H null and H1. Okay. So nak state H null and H1, kena tengok table. This table biru tadi yang saya letak. Okay, this table. So this table and this one, hypothesis statement. Yang ini yang awak kena tengok. So baca balik soalan, dia kata, it is known that on average, ada perkataan average, meaning that parameter yang kita berminat adalah mu. Okay. a computer technician need at least 3.2 hours to solve a problem. So dia perlukan at least, sekurang-kurangnya this one. Dia ada perkataan at least 3.2 jam. So kita nak letak dekat H0 apa, H1 apa? Apa statement? Sekurang-kurangnya meaning that at least 3.2 atau more, kan?
Greater.
Greater. So mu greater atau equal to 3.2 hours. Okay, itu awak punya H0 versus complement mu less than 3.2 hours. Okay, sebab dia ada perkataan this one at least, so it is greater atau equal. Okay, greater or equal. Alamak, hilang share screen. Stop presenting. Okay. Okay, nampak? Saya share screen sekarang.
Nampak Pak.
Nampak So dia ada perkataan this one. It has the word average. So kita tahu testing on the mean at least 3.2 hours. So ada perkataan at least meaning that lebih besar atau sama dengan. So ini adalah H0 punya claim atau statement yang kita nak claim. So H0 awak mu greater or equal to 3.2 hours versus mu less than 3.2 hours. Okay. So kalau tengok dekat table biru, ianya adalah yang mu greater. Okay. Your mean is the one that is greater. So kalau tengok mu greater meaning that is the first statement. This one. Mu greater than mu naught versus mu less than mu naught. So ini adalah testing kita atau setara juga dengan yang this one, tapi saya lagi prefer awak guna yang this one. So dia akan jadi untitled. Tapi kita bukan T test, kita adalah Z test. Apa benda asyik? Hilang je share screen ni. Parok betul lah. Okay, nampak Saya share screen. So dia akan jadi the first one in the table. Tapi kita punya adalah okay, now I wonder why I can't share the screen. Jeng, 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 jeng. Something's up, something's up. Hello, darkness, my old friend. I want to share my screen. Okay, can you hear me?
Yes.
Okay. Something wrong lah dengan ni. Tak sure lah, either the connection or the device that I'm using currently. Okay, tak apa. So tadi kita dah tengok dia punya statement. So ini adalah kena buka balik BENG. Note with chapter 3 underscore 2. Okay. Traditional way sometimes works better. Okay, so hypothesis statement kita adalah this one. Okay, kita tengok example tadi. So ini adalah kita punya statement. This one. At least 3.2 hour and average. So this is your claim. Okay. So kita tulis dekat dalam the hypothesis testing. First thing first, state the H0 and H1. State the H0 and H1. Okay. So awak akan ada H0 mu greater than 3.2 hours. Sebab dia nak cakap okay, H1 mu less than 3.2 hours. Dia punya complement. So take a look at this one. Awak ada tanda lebih kecil dekat sini. So kita tahu dia adalah one tail test. Yang mana ianya akan jadi this one. Lebih kecil. So rejection region awak akan jadi dekat sini. Okay. Rejection region and this is your acceptance region. Okay. So itu maklumat yang terus kita dapat daripada dia punya H0 dan juga H1. Okay. So step kedua, choose significant level. So soalan bagi alpha sama dengan 0.01. Okay, given dekat dalam question. This one. Alpha equal to 0.01. Okay. So yang ketiga, choose test statistic. Done class with this one.
Done.
Done. Okay. So test statistik daripada sini kita tengok n is greater or equal to 30 sigma unknown. So dia adalah case 3 that is Z distribution. Okay. So test statistik Z akan sama dengan X bar minus mu S over surd of N. So dia bagi X bar sama dengan berapa? 2.8. Okay. 2.8 tolak dengan population mean 3.2 bahagi dengan S yang dia bagi adalah 0.14 divide by surd 30. So dapat berapa jawapan dia? Dan
Done.
okay. So berapa jawapan? Yang ini.
Negatif 16.65.
Betul ke 16? Bukan 15?
Negatif
15.
15.38.
Negatif 15.6492. Dapat?
9649 lah.
649 berapa? Berapa ya?
Negatif 15.649 lah.
Betul lah, 6492. Saya ambil 4 titik pula. Pada sini choose test statistik 3, and then yang keempat critical region. Okay, critical region based on alpha. Okay, from here since SH1 awak mu less than 3.2, so ada tanda less than, so this is a one tail test. Okay, reject H null if Z less than Z. So kita tengok dekat table ni. This one. Untuk the first one yang ada Z. Okay. So this one. Reject H null when Z is less than negative Z alpha. So ini untuk case mu less than mu not. Mu greater or equal not. Okay. So this one. Reject H null when Z less than negative Z alpha. Meaning that from here, when Z less than negative Z alpha. Okay. So alpha equal to 0.01 negative Z alpha. So if you do the drawing here, you are going to have like this. Okay, ini rejection region negative Z alpha. So by using table of standard normal, awak tengok negatif Z 0.01 dapat berapa? Okay. Tengok dekat table of standard normal, negatif Z 0.01. Meaning that dekat dalam, nyampah pula aku. Dekat dalam dia is 0.01. So berapa nilai kiri kanan? Berapa? Nilai Z 0.01. Negatif berapa?
2.33.
Okay, betul. Negatif 2.33. So dapat dekat sini adalah negatif 2.33. Okay. So if you draw the drawing, it is like this. Negatif 2.33. Okay, if you draw the drawing, it is like this. Negatif 2.33. So ini adalah awak punya rejection region. Kenapa ambil belah situ? Sebab dia ada tanda lebih kecil. Okay. So we take that one as your rejection region negatif 2.33 and tengok test statistik awak. Test statistik awak adalah negatif 15. Okay. Negatif 15, so dia akan masuk dekat mana? Dekat dalam lantau berlorek atau yang tak saya lorek?
Tak berlorek.
Tak berlorek, salah. Negatif 233 dekat sini. So negatif 15 must be somewhere. Negatif 15.6492 mesti yang lebih kecil daripada negatif 2.32. So yang kita boleh buat keputusan as the test statistik, okay, Z equal to negatif 15.6492 0.6492 fall in the rejection region. Okay. So decision kita adalah we reject H null. Sebab yang saya lorek ini adalah rejection region. Yang tak lorek ini adalah acceptance region. Okay. So ingat tadi rejection region is reject H null. Acceptance region is accept H null. Okay. Keputusan kita based on reject atau accept H null. So kita decision, okay, reject H null. Conclusion based on apa? Keputusan kita reject H null. So conclusion kita will be based on what? Oi, conclusion based on what?
Average.
Huh? Conclusion will be based on H1. Sebab awak ada dua pilihan, H null atau H1. Awak buat test and then dapat keputusan reject H null. Meaning that yang awak terima adalah H1. So conclusion awak will be based on H1. Okay. So contohnya macam kau ada dua makwa lah, A dan B. Kau test, kau tengok siapa yang masak sedap, banyak duit, lagi apa nama? Cantik and so on. So dapat tengok-tengok B punya kriteria lebih daripada A. So reject A. Meaning that yang awak pilih adalah awak yang B. Faham Itu maksudnya. So sama juga dengan case ni. Keputusannya dia reject H1. That means your conclusion will be based on H1. So step kelima, the conclusion yang kita nak buat adalah the conclusion from the sample. Okay. So from the hypothesis testing, we find that a computer technician need less than, sebab H1 awak adalah less than 3.2 hours, okay, in average, okay, to solve troubleshooting a problem of troubleshooting. Okay, so itu adalah conclusion. Our conclusion is based on H1. So faham semua? Oi, dapat? Ya, faham ya?
Memang panjang conclusion dia.
Faham, Cik.
Conclusion panjang based on kalau nak buat pendek boleh juga awak tulis je lah conclusion, the computer technician need less than 3.2 hours to solve problem of troubleshooting. Pun accepted. Okay, dapat So this is how you perform the hypothesis testing. Nanti dalam chapter berikutnya memang semuanya hypothesis testing. Because hypothesis testing is actually the main idea of statistic. Selain daripada data analysis. Okay, ada soalan? Yang dah cuba baca the next question. Kita akan buat satu atau dua example lagi dan kita akan continue hari Jumaat. Done? Ada soalan?
Dan
Done. Adwa ni, ada?
Ada doktor.
Okay. Faham so far? Okay, kita tengok next example. Example exercise 7.2. Okay. So kita tengok exercise. Done this one? Hui. Done?
Dah.
Dah. Okay. So exercise 7.2. An engineer of an automobile company wants to check if it is true that the mean time to stop when brake is pushed, a vehicle with ABS will take exactly 25.4 seconds during heavy rain. Okay. A random sample of 40 cars has been tested and give a mean of 26.2 seconds and a standard deviation of 2.3 seconds to stop. Can you help the engineer to make a conclusion? Use alpha equal to 0.03. So macam case tadi lah, dia nak tengok satu company tu yang buat kereta, berapa masa yang dia ambil untuk brake, untuk stop kereta bila brake ditekan pada waktu hujan turun. Okay. So kereta tu ambil masa 25.4 second. Lambat juga ni. Okay. So daripada sini random sample of 40 cars dia test and then dia dapat daripada 40 sampel yang dia buat tu, eksperimen tu 26.2 is the mean dan standard deviation is 2.3. So if you list down all the information, 40 is what? Given and kecil sama dengan 40. 26.2 apa?
S bar.
X bar equal to 26.2. 2.3?
S.
Okay, S sama dengan 2.3. Alpha equal to 0.03. So, N greater than 30, sigma unknown. So, we know that this is case 3. So, dia akan follow Z distribution table. So, awak dapat Z test sama dengan X bar minus mu divided by S over surd of N. Okay. So itu adalah dia punya information given. So yang kita nak claim, nak letak dekat H0 yang mana? Which are the statement that we want to put in the H0?
Exactly 5.4 second.
Yep, true. Is it take exactly 25.4 second? So ada perkataan exactly. How you are going to put this statement? Which sign to use?
Mu equal to 24.5.
Yep, betul. Okay. Mu equal to 24.5 and the complement will be?
Mu less than 25.4.
Salah.
More than.
Not equal.
Not equal. Yep, betul. Okay. Because the statement is exactly the hypothesis testing. Okay. So first thing first, state your H null and H1. Okay. So H null mu equal to 25.4. Sebab dia kata exactly, the complement must be tidak sama. Okay. H1 mu does not equal to 25.4. Okay. 25.4 second. So if you take a look at table biru, okay, tengok table biru. So this one adalah two tail test. Okay. So awak punya rejection region nanti akan ada dua sided. This one. Okay. So this is the first step. List down your H null and state your H null and H1. So step kedua, choose alpha. Dia dah bagi alpha equal to 0.03. So simple sangat step kedua. Step ketiga, the test statistic. So the test statistik tadi kita dah tengok n greater than 30 sigma unknown, kita akan dapat dia adalah Z test. So Z sama dengan X bar minus mu S over cert of N. So your X bar is 26.2 minus 25.4 divided by S adalah 2.3 cert 40. So cuba kira what is the answer.
Oh, 1998.
Benda? Dapat? Berapa set?
2.1998.
2.1. Oh tadi kau cakap 2. Okey. 2.19.
Dua.
Dua. Dengar tadi 2. Tu bahasa orang mana? Terengganu, Penang. Okey. 2. Johor tak ada, Johor 2. 2. Dia ada banyak e. Okay, so itu adalah step ketiga. Step keempat, apa step keempat? Establish the critical, the rejection region, critical region. Okay, critical region and decision. Okay, so since awak punya tanda H1 mu does not equal 25.4, this is a two-tail test. Reject H null when Z less than negative Z alpha over 2 or Z greater than Z alpha per 2. Okay. Yang ini daripada refer table biru. Okay. Yang ada tanda H1 non-equal sign. Okay. So, alpha equal to 0.03, Z alpha over 2 equal to Z 0.015. So tengok dekat dalam table Z of 0.015 berapa nilai dia. So awak akan dapat two tail. Negatif Z alpha dan juga positif Z alpha. per 2. So tengok dekat dalam table of standard normal distribution, Z 0.015 equal to what?
Negative 2.17 cik.
Betul. Negative 2.17. So memandang kita ambil yang positif dan juga negative value. So you get negative 2.17 here and 2.17 dekat dia punya another side. Okay. So boleh tengok kalau ni 1 tolak 0.015. Okay. So that is dia punya complement. So ini adalah acceptance region. So this is your acceptance region. Okay. This is your rejection region. And this is also your rejection region. Okay. So 2.1998 jatuh dekat mana? Acceptance atau rejection region?
Rejection.
Rejection, okay. 2.19 positif dan dia maybe somewhere dekat sini. Ini adalah 2.1998. Okay. So Z equal to 2.1998 falls in the rejection region. So decision kita adalah reject H null. Okay. So yang last step, conclusion based on H1. Okay. So sebab awak reject H null, meaning that awak terima H1. Okay. So conclusion, there is enough evidence to conclude that the mean time to stop a vehicle with ABS, okay, with ABS will not take exactly 25.4 second. Okay. So maksudnya tak betul lah claim dia tu. Dia tak ambil masa 25.4 pun. So masanya lebih atau kurang tu nanti kita kena buat further testing pula. Tapi itu kerja engineer tu lah. So itu adalah berkaitan dengan hypothesis testing. So kita tengok lagi satu last example sebelum kita stop. Dan dah boleh tengok example page 340 Whirlpool. Another last example before we end our class. Sayang. Kucing aku dah tidur dah. Kucing saya yang dari tadi duduk ni dah tertidur. Saya harap semua student saya masih bernafas dan bernyawa. Masih apa nama? Masih sedap bukan bernafas dan bernyawa. Douglas.
Siap doktor.
Dan yang lain dan Buja. So yang done cuba buat dulu exercise 7 point exercise 340. A random sample of 100 recorded deaths in the United States during the past year show an average lifespan of 71.8 years. Assuming a population standard deviation of 8.9 years, does this 8.9 years. So does this seem to indicate that the mean lifespan today is greater than 70 years? Use 0.05 level of significance. So dia buat kajian kat US. Dia nak tengok lifespan manusia. Lifespan manusia, dia kata betul ke orang-orang kat US tu, Mak Saleh tu hidup lebih daripada 70 tahun. Dia punya lifespan. Okay. First list down information given. And then tengok apa H0, H1 and see what kind of test that we want to do. So this one given, okay, n sama dengan 100. And average lifespan x bar sama dengan 71.8. Okay, 8.9 years. Dia kata population standard deviation. That means this is what?
Sigma.
Sigma, betul. Okay. Sigma equal to 8.9 tahun. Okay. So, does this seem to indicate that the mean lifespan today is greater? So, ini adalah awak punya claim atau andaian yang kita berminat. So, this is the claim. And alpha equal to 0.05. So from the information given, n greater than 30, sigma is known. Okay, that means this is case 1. So it will follow Z distribution. So your test statistic will be Z equal to x bar minus mu over sigma per set n. Okay, so list down the information given. Okay, so from here, list down your H0 and H1. H0 and H1, we want to study on the lifespan. So mu is less than 70 and mu greater than 70. Because we want to test, is it true that the mean lifespan is greater than 70? So this is the hypothesis statement. So we can see that this is a one-tail test. Okay. And then step kedua, you were given significant level. Okay. Alpha equal to 0.05. And then step ketiga, you can carry on with the test statistic. Okay. Z equal to x bar minus mu sigma over set of n. So you dapat x bar is 71.8 minus 70 divided by sigma is 8.9 over set of 100.
So kalau kira dapat 2.0225. Okay, so this is the test statistic. Step keempat, tengok awak punya rejection region. Okay, so reject H null when Z greater than Z alpha. So Z alpha equal to Z 0.05. So take a look from the table, 0.05 you akan dapat dia sama dengan 1.645. Okay. So this one. .645. Okay. Yep. So kita akan ambil 1 tolak this one equal to the other side, that is Z 0.95 sama dengan 1.645. So this one 0.95. Sebabnya dia adalah greater than. So greater than here, we know it will be rejection region dekat belah kanan. Dekat belah kanan, kalau tengok dekat table, yang ini is 1 minus. Okay. Kebarangkalian dekat dalam ni adalah 0.05. So 1 minus 0.05, kita dapat 0.95 yang the positive value. Okay. That is why kita ambil Z of 0.95. Ni macam yang chapter 2. How to take a look at the table of standard normal distribution. Dan daripada sini awak dapat test statistic is here. Let's say this is your 2.0225. Okay. Test statistic. Okay. Z equal to 2.0225 falls in the rejection region. Okay. So reject H null. Conclusion will be based on H1. So from here we can conclude there is enough evidence to conclude that the mean lifespan today in the US is greater than 70 years. Okay, dapat Oi, senyap je.
Dapat.
So yang ini sebab dia adalah one tail, kalau awak tengok dekat table biru tu, dia adalah dekat side yang second column, second row of table tu. Z greater than Z alpha. Walaupun dia bagi alpha awak 0.05, tapi sebab dia adalah area belah kanan, that is why kita ambil dia punya complement is 1 tolak 0.05. That is 0.95. So tengok dekat dalam table of standard normal distribution, 0.95 sama dengan 1.645. Okay. So sebab tu kena tahu rejection region tu dekat belah mana. Sama ada it is positive value or negative value. Sama ada di belah kiri atau belah kanan. Right tail atau left tail. Okay. So ada soalan so far? Oi, senyap je.
Tak ada doktor.
Tak ada yang lain-lain mana?
Sekejap.
Amar okey? Ada soalan Amar?
Okey, okey.
Okey. Adwa, Daus, dan siapa lagi? Suzihin.
Okay.
Okey. Lemah ni semua suara. Baru second day of puasa. Okay, so kalau tak ada soalan, we can end our class. Awak boleh try example lagi 2 tu, nanti kita continue dengan next class. We take a look at the example and how to solve that one. Then maybe next week kita boleh tengok lagi macam mana nak selesaikan guna Excel. Tapi actually untuk test-test daripada chapter 2, chapter 3 ni kalau nak tekan Excel, satu ni je lah, satu button je. Di dalam chapter ANOVA, nanti chapter 5, 6, 7, 8 yang itu banyak guna Excel. Okay, so if there is no question, we end our class and continue hari Jumaat.